Hi guys, welcome to Ignite India. This is the expert session of Mr. Anand sir of Quantitative Aptitude. Sir, you can start the session now.
I can. Great. So meanwhile that we are waiting for a few more people probably to join, I'll take a couple of minutes because I need to understand certain informations from you all. In the chat box, can you type in if there is any other examination apart from Nift, NID, UCID, Nata that you guys are preparing for? Is there anyone who's preparing for any other exam apart from Nift, NID, Nata, UCID, anything related to design and fashion? Taking that off, is there any other exam that any one of you is preparing for? Can you write that exam name in case you guys are? No? Okay, great. For seed, yeah, you seed, all similar, Sandeep. But except these, there are exams which caters to, yeah, Sheetal. So except exams which cater to design and fashion, is there any other exam that you guys are planning to write? That's the idea. So now Nift is again included into the fashion exam. So I'm looking into an exam which is not with respect to fashion or not with respect to design. Okay, Preeti, when you say JEE, are you trying to approach the design fashion criteria or the or the engineering side of it? Okay, right. Okay, so that's a lot of people with architecture into the place. Right, guys, so we are going to continue with the classes that we stopped yesterday. We went into factors, and I presume that you guys have gone through the videos, understood the topic, understood the concept, and good to go for the next set of questions or next set of understanding. So one thing that I would like to begin this entire class with is a question which is related to what we did yesterday. So the question is on your screen right now. Okay, the question is that there's a rectangle which has an area of 576 square centimeters. How many such rectangles can be created with integral sides? So can you try solving this and putting across your answer options in the chat box? Karen, what are integral sides? Integral sides means sides which are integers in nature. So you cannot have a 10.5 centimeter as a side. Either it has to be a 10 centimeter or it has to be 11 centimeter. It cannot be fractions, right? So I'm giving 1 minute for you to see where exactly you can reach, and then we will try solving this particular question. Preeti, Didn't attend the class yesterday? Okay, fair enough. But then I would suggest you please go back to the YouTube videos that exist under Ignite Education. Go through the video and understand the concept again. And if you have doubts, you can always reach to me. All right, guys. So first, let's, Sanika says 18, Ritika says 21. Deepika says about integral sides. Okay, Deepika, so let's, integral sides, Deepika, means that I need to have a side which is an integer, okay? So for example, 1, 2, 3, 4, 5, these are integers, right? So I can create, for example, I can create a rectangle whose length is, let's say, 5.5 centimeters. I can create one. But unfortunately, 5.5 is not an integer. It is a decimal value, right? So I am now looking in this question, I am only looking into rectangles which has integer as its length and integer as its breadth. Okay, so there are a few people who have answered, so let's understand this. Now, what is an area of a rectangle? So if I look at a rectangle, it has a length and it has a breadth, and the area of a rectangle is always given as length into breadth. Okay, so it's given to me that this area, length into breadth, is 576 square centimeter. Which means when I look at this, I understand one thing, that 576 I am getting by multiplying L and multiplying B. So let's take an example here. Can I get 12 by multiplying 1 and 12? Yes. Can I get 12 by multiplying 2 and 6? Yes. Can I get 12 by multiplying 3 and 4? Yes. Okay. These are all integral values, correct? But the other part that you have to also figure out is that all these values 3, 4, 2, 6, 1, 12, all these values are also factors of 12. Means if I have to find an area of 576 using L into B, I know that L and B now has to be factors of 576. I hope you all understood this concept. That is, L and B should also be factors of 576. So first and foremost rule for me is to see how many factors 576 has. Now, if we remember the first class that we did, which was 1 square, finding squares up to from 1 to 25, we realized that 576 is nothing but 24 square. And 24 itself is nothing but 8 into 3. 8 again is nothing but 2 cube into 3. And thus this becomes 2 cube whole square, which is 2 power 6 into 3 square. I hope you are all clear till here. Now, so 576 is nothing but 2 power 6 into 3 square. Now 2 power 6 into 3 square means a number of factors of 576 is 6 plus 1, 7, 2 plus 1, 3. 7 threes are 21 factors. Okay. So I have got the number of factors of 576. Now what am I looking into? If I concentrate on the left hand side, I am looking into an area of 12. And how do I get this area 12? I get this area 12 by multiplying two values which are factors of 12. So I have to pick two values at a time to multiply and get 12. Similarly, if I have to get an area of 576, I have to pick two factors at a time. Now, if you have 21 factors with you, How many times can you pick two values? You can pick two values either 11 times or 10 times. Okay? And that's where I can create either 11 rectangles or 10 rectangles. I guess many of you are confused at this stage, but I want you guys to throw me light if you're confused only in this step or you're confused in everything. Just unmute yourself and throw me a light.
So only the last step, like how do you get 11 and 10?
Okay, right, Karen. So I'm assuming the others, you are also with Karen and you are confused only with the last step. Now, before we get into that, the last step part, can you guys tell me, type in if you want in the chat box, is a rectangle also a square? Type in your chat box, is a rectangle also a square? Okay, so I have a mixed answer here. Someone asked from where we get, just a minute. Okay, Ragini, if you remember, I don't know whether you attended yesterday's class, but if you remember yesterday's class, the number of factors that we can calculate was always take the power and add 1 to it. So that's when it becomes 7. Take the power, add 1 to it. That's where it becomes 3. Multiply these values and that will give you the number of factors. Okay. Now coming back to our question. Is a rectangle also a square? Absolutely no. A rectangle is not a square. What we know is a square is also a rectangle. Okay. Please understand the difference between the two. When you define a square, you always define a square as a four-sided figure with all four sides to be equal. But when you describe a rectangle, you describe a rectangle as a four-sided figure with opposite sides to be equal. Okay, so a rectangle is never a square, but a square is always a rectangle. Means if this question is asking that how many rectangles can be created, please remember that even if I end up creating a square, it is still counted because a square is also a rectangle. If I do not create if I do not create a rectangle, but I create a square, the square will also be counted as a rectangle. Okay, but a rectangle can never be counted as a square. So remember this part. So now, so in this case, now when I'm coming here, asking for, asking for when my total number of factors is 21, what have I found here? I have found that my total number of factors is an odd number. And when my total number of factors is an odd number, what does it signify about the number? That it is a perfect square. A perfect square means it should have a square root, right? So 576 का square root क्या होता है? 24. So now tell me, can I have a rectangle? Can I have a rectangle with side 24 and 24? Yes? Very much yes. Okay? Now, how many 24s you require here to create this rectangle of area 576? You require two 24s. But when you are listing down your factors, how many 24s are there in this factor? There is only one 24 in this factor, which is the middle value. Remember yesterday what we did? We got list of factors. The middle value of those factors was always the square root of the number. Okay, so there will be only 124 in this case. But to create this square, how many 24s I require? I require two 24s. That's why I am adding one. Because I require one more extra 24, I am adding one extra factor and then dividing by 2. and thus I'm getting 11 rectangles. But let's now assume that you do not want to create this rectangle. You do not want to create this square. If you do not want to create this square, will you be using 24? You will not be using 24, which means out of these 21 factors that you have, you will not be using one of the factor, which is 24. So if you are not using one of the factor, you will subtract 1 and divide by 2. Are we clear with this concept, guys?
Yes, sir.
The others, can you type in? If someone is still no, can you unmute yourself and ask? Right, great. So there was someone who said Nuha. Nuha, no, not every rectangle is a square. Obviously not. Okay. But every square is a rectangle. Clear? Because it falls under the definition of a rectangle. Great, guys. Now let's come into the fact of getting into today's session. What's today's session? Where are we landing into today's session? Today's session is going to be more of finding LCM and getting into understanding LCM as a model. Okay. Now, what do we mean by LCM as a model? Let's start with an example. Before that, let me start with an understanding concept. Let's say that I have a number 24. If I'm dividing this number 24 by 5, what quotient I get? I get a quotient of 4, 5 fours are 20, and I get a remainder of 4. Okay. Someone is unmute. Manish, can you mute yourself? Thank you. So I have a number 24 and I'm dividing this number 24 by 5. I get a, so 5 fours are 20 and 4 is a remainder. So what are the various nomenclature or names given to these parameters? This value is always called as the quotient. This value is always called as the remainder. This value is always called as the divisor. And this number of yours is always called as the dividend. Okay. So you have 4 parameters that you have to remember. 1, divisor, the number that you're going to divide by. 1, the number itself, which is called as the dividend. 1 is a quotient and 1 is a remainder. Now, if you look at this value, you can always say that 24 is equal to, 5 into 4 plus 4, correct? Which means you can always say that your number is equal to the divisor that you're dividing by into the quotient that you've got plus the remainder. Now, can I write this way also? 5, 5s are 25 and minus 1. Yes, no one stops me from writing this. The only thing is we never give an answer as minus 1 in a remainder part, which means I can still write 24 as 5 into 5 minus 1. Okay, which brings us to one of the most important concept, that a remainder, when you find, can either be positive or it can also be negative. Okay, it can be positive where in this case, or it can also be negative. But remember this, that whenever I have to answer a question, mark an answer to a question, my answer is always searching for a positive remainder and never searching for a negative remainder. We will use negative remainder only to solve problems and reduce the effort of solving problems, right? Throw any doubts, or you're all clear with this? Sonali, Navina, don't worry whether you have done the classes earlier or not. From this slide onwards, this becomes a new class types, okay? Don't bother about what you have done earlier. From this slide onwards, the previous one was obviously the continuation, but from this slide onwards, it's going to be completely like a new class for you. So don't bother. Do you understand this, what we have done here? This is exclusively going for Navina and Sonali. Right, great. So you can have two kinds of reminders. Just keep that in mind, the positive and the negative. Now let's look into.
Sir.
Yes, Shiva.
Sir, can you repeat this once again, sir?
Okay. So Shiva, always remember. So tell me this, Shiva. If you are dividing, let's say, 23 by 4, can you tell me what is the reminder you get when you divide 23 by 4?
3.
Right. So you say 4 5s are 20 and you get a 3 reminder, correct? So which means you can say 23 is 4 into 5 plus 3. Correct? Now,
Yes, sir.
if you see what is 4? 4 is your divisor. Okay? The value that you're dividing by. What is 5? 5 is your quotient. And what is 3? 3 is your reminder. So you can always write a number as divisor into quotient plus the reminder. Are we clear till here?
Yes, sir.
Now, but if you look at 23, 23 is not only 4 5s are 20 plus 3, 23 is also 4 6 are 24 minus 1. Means with the same divisor, I can have two different quotient and two different remainder. Whereas one remainder is going to be positive, that plus 3, one remainder is going to be negative. Okay, so in any problem when you're dividing a value, you can always get two kinds of reminders. One is a positive reminder and one is a negative reminder. So you can use any one of these two to actually solve a question. Did we understand, Shiva, till here?
Sir, this positive and negative I'm not understanding.
Positive and negative you're not able to understand. Okay. This is, you're clear with the positive reminder. 3 is a reminder you got, correct?
Yes, sir.
Is it positive or negative?
Positive.
Positive. So you got a reminder which is positive. Now, let's look into, is it wrong if I write it this way? 23 I'm dividing by 4. 4 6 are 24 minus 1. Is this wrong or is it right?
Wrong.
Why wrong?
Sir, it's coming greater number.
What is greater number?
24.
No, but so what? I am dividing 23 by 4. I have a remainder of minus 1. So?
Correct, sir.
You're forcefully saying now correct. Okay, anyway, Shiva, the point is this, that what do you mean by a reminder? Reminder is that value, okay? Reminder is that value, which if I remove from the number, then the number is divisible by your divisor. So in this case, you got a reminder of 3. So 3 is that value, which if I remove from my number, then the number you get is divisible by 4, correct?
Yes, sir.
This is not only for Shiva, but for all of you. Right. Now let's come here. What is the reminder I got here? Minus 1. Minus 1 is that number which if I remove from my number 23. Remember, minus 1 is the remainder. So minus 1 is that number which if I remove means minus, right? Subtracting. So if I remove from my number 23, what do I get, Shiva, here? 23 minus of minus 1?
24.
Which is divisible by 4, correct?
Yes, sir.
So in which case, I can always have a remainder which is positive or remainder which is negative.
Okay.
Okay. So basic way of figuring out is, if there is a number, if I'm dividing a number by, let's say 6, and if the remainder, positive remainder, let's say positive remainder, you guys are getting is 5. Then can you quickly tell me what is the negative remainder? -1.
Minus.
The difference, 5 minus 6. What is 5 minus 6? -1. That becomes a negative remainder. If you are dividing, if your positive remainder is 4, can you quickly tell me what is the negative remainder? 4 minus 6. What is 4 minus 6?
-2.
-2. If you are getting a positive remainder of 3, can you tell me what is the negative remainder?
-3.
If you are getting a positive remainder of 2, what is the negative remainder?
-4.
If you are getting a positive remainder of 1, what is the negative remainder?
-5.
That's it. So in this case, now come back to your question, Shiva. You got a positive remainder of 3. What did
Yes,
you
sir.
divide it by? You are dividing it by 4. So if you got a positive remainder of 3, what will be a negative remainder?
-1.
That's what you got here. So you have to subtract these two to get the negative remainder. Did you understand this, how to generate negative reminders?
Yes,
Once
sir.
you have the positive reminder, this becomes easy to generate the negative reminder. Now let's understand why we have come, where we are getting it. Okay. So I am now, okay. So we got to understand that a number can always be written as divisor into quotient plus the remainder. Okay, so I can always write it in this format. Now, let me start throwing a question. So if I say that there is a number and this number is being divided by 3 and the remainder that you get is 1. Okay guys, there is a number and you are dividing this number by 3 and the remainder you get is 1. Can you tell me what kind of numbers, or can you tell me example of numbers which I'm talking about? I'm dividing by 3 and I'm getting a remainder of 1. Can you give me an example of numbers? So, right, 4 is what Vidipta has said, Akriti said 10. Sanjana, multiples of 4? Are you sure, Sanjana? Because if I place multiple of 4, 8 is a multiple of 4. When I divide 8 by 3, what is my remainder? 2. Okay. Right. So not all multiples of 4. So 4, 10. Yeah, Stuti. Thank you. So all numbers which will be in the form of 3 into quotient plus the remainder. Remember, this is my number format. So any number which is in the form of 3 into quotient plus the remainder is now falling under this category. That is this number where I start placing Q value as, let's say 1, 2, 3, 4. When I continue placing Q value, I get different set of numbers. If I place Q value here 1, 3 into 1, 3, 3 plus 1, 4. 2 here, 3 2s are 6 plus 1, 7. 3 here, 3 3s are 9 plus 1, 10. 4 here, 3 4s are 12 plus 1, 13. So like this, if I start placing the values, I will get all the numbers which will fall under this category of 3 into Q plus 1. Okay. So that's why this format that we are using becomes utmost important. So now let's complicate it slightly. Yes, please.
Sir, this 4, 7, 10, 13 house.
Where is Q? Q is here, right, Shiva? What are the Q values you are saying? You are saying if Q value is 1, if Q value is 2, if Q value is 3, if Q value is 4. So start placing 1, 2, 3, 4 in place of Q value. What are the values you're going to get? When you put Q as 1, what do you get?
4,
That's what you got. When you put Q as 2, what do you get?
7,
That's what you got. When you put Q as 3, what do you get? 10. So
10.
all these values will now be giving a remainder of 1 when divided by 3. Got it?
Yes, sir.
Okay. Now guys, so now let's go one step ahead. So now let me say that, okay, Shiva, you may have to mute yourself if you're not talking. Okay, so now we will do this. So I want you guys to tell me a number. Tell me a number which, if I divide by 3, gives me a remainder of 1, and wait, don't jump. And when I divide by 5, it gives me a remainder of 1. So I am talking about one number which when divided by 3 gives me a remainder 1, and when divided by 5 gives me a remainder 1. Can you guys tell me the numbers that exist? So Preeta is already quick. Preeta says 16. Okay, Preeta, 16, I agree. Akriti also says 16. But tell me, guys, is 16 the only number? Do you have anything else? Stuti, impressive. Stuti says 15. 15p plus 1. So now let's understand this entire portfolio here. So first, let me take only this portion. You are asking me a number which when divided by 3 leaves me remainder 1, means a number which is in the format of 3 into quotient plus the remainder. I hope you all have understood this, now writing this format. Okay. Now when I start placing Q value, as 1, 2, 3, 4, 5, 6 and so on, I should get various numbers, okay, which satisfies this condition. So let's look into this. 3 ones are 3 plus 1, 4. 3 twos are 6 plus 1, 7. I'm writing it in a very simple steps, guys, so that each one of you understand. Then we will jump into the smaller one, easier ones. 3 threes are 9 plus 1, 10. 3 fours are 12 plus 1, 13. 3 fives are 15 plus 1, 16. Right? 3 sixes are 18 plus 1, 19. 3 sevens are 21 plus 1, 22. So now you guys have understood. But if you look at this now, look at this series. Do you see that the value is increasing by 3? So if the value is increasing by 3, all I have to do is keep increasing it by 3. So it becomes easy for me. I do not have to struggle much. Okay? I just keep increasing by 3 and I get the various kind of values that I want. Clear? Now, you are also now saying that I am in search of a number which when divided by 5, so 5 when I divide, I get a quotient. Now it's very important here that I change the quotient to Q1. Okay? The reason being, when I divide a number by 3, whatever quotient I get, I will never get the same quotient if I'm dividing that number by 5. है ना? 23 को 3 से divide किया, what quotient you got? 7. But 23 को 5 से divide किया, what quotient you get? 4. So the quotient will vary for the same number when your divisor varies. So I would rather use it as Q1. And we are now saying that when I'm dividing by 5, I get a quotient and then there is a remainder 1. So again, what are the Q1 values? Q1 values will be 1, 2, 3, 4, 5, 6 and so on and so forth. Okay. So let's start placing Q1 values. If Q1 is 1, 5 into 1 plus 1, that is 6 is the value. Then I know from my previous experience, I know this, that all these values are now going to increase by 5. So 6 plus 5, 11, plus 5, 16, plus 5, 21, plus 5, 26, plus 5, 31, plus 5, 36, and so on. Okay. Are all of you clear till here?
Sir,
Do you
can
have
we
any doubts? Please raise.
continue in the next session because this is about to end? Can I ask
Okay,
everyone to join?
okay.
Okay. Guys, please rejoin the same link again in another 1 minute, please.